Hello everyone, my name is Al-Rfai. Today I will present our article predicting energy consumption for UAV-enabled MEC using a machine learning algorithm. Outline: Introduction, prediction using a neural network, recurrent neural network, keystep prediction, multi-UAV network model, simulation results. Conclusion. Introduction: Machine learning algorithms are widely used in 5G network, where the use of machine learning can lead to far-reaching development in the applications or infrastructure. Moreover, machine learning can be used to improve network management, avoid congestion, and optimize resource allocation, as well as analyze data and make decisions in real time or offloading. There are many machine learning algorithms that can improve the energy efficiency of 5G network, such as neural network-based techniques that can help in efficient processing of big data. Moreover, integrating artificial intelligence and machine learning technologies into wireless network can leverage intelligence to solve various problems. Thus, the combination of artificial intelligence and machine learning drones seems to be tightly integrated into multiple discipline application and in all layers of network, promising unprecedented performance improvement and reducing complexity. Network traffic prediction is important operational and management function for any network data network. It has significant role in today's increasingly complex and diverse network traffic prediction is also more important for IoT network for providing reliable communication. The artificial neural network has been successfully applied for traffic prediction. Predicting using a neural network. In recent years, neural networks have received increasing amount of attention as very popular for forecasting and data mining tools. They can be used for prediction with various levels of success. The advantages of neural network includes automatic learning only from the measured data dependency without any needs to add more information. Artificial neural network, like people, they can learn by example whose function is determined by the network structure, connections between elements, and processing performed at computing elements or nodes. Once the network has been configured for specific problems, that network is ready to be trained by adjusting the values of connection weights between elements. An artificial neural network is trained using historical data with the hope of discovering hidden dependency that it will be able to use them for prediction of the future. It is possible to predict several types of data with time series. The time series displays the development of values in time, and these values can be influenced by other factors. The time series represents discrete history of value, and from continuous functions it can be acquired by sampling. Recurrent neural network. Nowadays, recurrent neural network has been proven themselves to be very successful, powerful predictive engine. Recurrent net differ from feed-forward neural network because they include feedback loop, whereby the output at the current time step it feed to the input to the next time step, and so forth for each subsequent step. As shown in figure, recurrent neural network, the recurrent model is trained by presenting the previous values of time series to input layers, and the network weights are adjusted based on error between the real output and the predicted output. Before training the network, the user must determine the number of hidden neurons in network and the stopping criteria for learning algorithm. One of the most famous time series predictor Narix neural network, which based on recurrent neural network. In time series problem, predicting future values for UAV time series from the previous values of those time series and previous value from the second time series of K. This type of prediction is called nonlinear autograph with external input or Narix network, and it can be written as follows. Keystep prediction. Keystep prediction is the task of predicting sequence of values in time series. In this approach, we apply the predictive model step by step and use predicted value of current time step to determine its value in the next time step. The procedure is repeated until the last value has been estimated. In this approach, it is adequate to implement a single model for making prediction. Research aim. In this paper, we implement time series prediction of energy consumption in MEC with multiple UAVs using recurrent Narix neural network. We studied the performance in 4 cases according to function of key step ahead prediction using a different number of hidden neurons. The prediction accuracy was evaluated using root square error and mean absolute percent of error. Implementing a multi-UAV network model. In this paper, for generating data set for machine learning algorithm, we simulated multi-UAV model based MEC. Multi-UAV network connected to base station via wireless channel, and this base station is equipped with edge computing server, as shown as in figure 1. UAV M has set of M independent computational tasks indicated by M, which must be processed locally in UAV-M or will be offloaded and executed either in one of the neighboring UAVs or remotely in edge computing server. The screen considers that UAVs stay unchanged during period when computations are offloaded, while it can be moved to another location during other period. Simulation results. In this work, we performed time series prediction using a MATLAB environment to implement and simulate the energy consumption of UAV-based MEC using a Narix recurrent neural network. We investigated the performance in 4 cases as a function of Keystep prediction using a different number of hidden neurons. The dataset were generated from MEC with multi-UAV models, and we also simulated the model using MATLAB. After collecting and preparing the dataset, we divided it into training and testing to evaluate the prediction accuracy for traffic data. We used the root square error and the mean absolute percent of error. The following table indicates the prediction accuracy for energy consumption. From the tablet result, the model has the predicted model using in the case one step prediction. One step prediction, we found that in case of 20 hidden neurons has the best prediction accuracy for root square and the mean absolute percent of error. The maximum average improvement in this case is 4.3%. Also, the model predicted with 17 hidden neurons has prediction accuracy approximately equal to that of the model with 20 hidden neurons. Moreover, the maximum average improvement 2.3. On other hand, the model predicted with 15 and 10 hidden neurons has the lowest prediction accuracy compared to the other. As shown as the table, in the case of 10-step prediction, the model predicted with 20 hidden neurons outperformed its competitor, and the maximum average improvement in this case 6.8. On the other hand, the model predicted with 17 hidden neurons has prediction accuracy approximately equal to that of the model with 20 hidden neurons. Moreover, the maximum average improvement is 5.7. In the case of using 15 step case, the prediction model with 20 hidden neurons has better accuracy than the others, and the maximum average improvement is 8.6. Also, the prediction models with 17 and 15 hidden neurons has approximate equal prediction accuracy, and the maximum average improvement is 4.4 and 2.6 respectively. In other hand, the prediction model with 10 hidden neurons has a lower prediction accuracy than the other. In the case of using 20-step predictions, the prediction models with 20 and 17 hidden neurons has semi-equal and better accuracy than the others, and the maximum average improvement 3.6 and 3.3 respectively. Also, the model predicted with 15 steps has lower performance than the others with 20 and 17 hidden neurons, and the maximum average improvement 1.6. On the other hand, the model predicted with 10 hidden neurons has the lowest prediction accuracies compared to the other. Also, from figure 5 to figure 8 shows the predicted models for energy in 4 cases according to the number of hidden neurons used in each cases and the corresponding key step ahead predictions. In each case, from the figures it can be seen that the predicted energy models change randomly all the time in all cases. Conclusion. This paper is about the technique for predicting energy consumption in UAV-enabled MEC using a recurrent neural network, NRX. This technique has advantages of remembering the historical data and providing a more accurate estimate of the future data and the time series. It also has advantages over other approaches to time series predictions in that it serves to maximize the accuracy of learning method over training iteration. As more data is added to the model is become smarter and can better evaluate traffic volume, which is important for real-time traffic forecasts. The prediction accuracy was evaluated using the Riemann square error when absolute percent of error. The simulation results show that the model predicted with 20 hidden neurons outperforms its competitor and has the best prediction accuracy in all cases. On the other hand, the model predicted with number of hidden neurons 10 hidden neurons has lowest prediction accuracy compared to the other. Many thanks for your attention.